All right, show of hands. Okay, not really. But I do wonder how many have heard the term AI winter? No worries if you're not familiar, because I'm about to break it down for you. Twice in history, AI got hyped, then totally flopped, leading to these periods we call winters, where funding dried up and progress stalled. And yet, here we are in 2025, and AI is practically everywhere. The question is, why now? To really get a handle on this moment, we have to look back. AI has been a dream for a long time, with bursts of incredible optimism. If you think back to the 1950s and 60s, it felt like sci fi was right around the corner. Researchers had early successes with things like simple chatbots or programs that could solve logic puzzles, and the belief was that general human level intelligence in machines was imminent. But then came the first AI winter in the 1970s. The reality check hit hard. The researchers trying to tackle more complex problems, like getting a computer to genuinely understand human language or navigate a physical space, ran into fundamental roadblocks. Picture this: getting the necessary data was a nightmare. Most information was not digitized back then, it was locked away in filing cabinets or written reports. Training AI models requires vast amounts of labeled data to find patterns, and collecting, cleaning, and digitizing that scale of information was prohibitively expensive and incredibly slow back then. Also, the computational power available was incredibly limited. We're talking about machines that filled entire rooms but had less processing power than your average smartphone today. Trying to run sophisticated learning algorithms or complex simulations on those early computers was computationally impossible or would take absurd amounts of time, making ambitious projects non starters. And the algorithms themselves, while clever, were often based on fairly rigid, rule based systems or simple statistical models. They lacked the flexibility, nuance, and ability to generalize or understand context that the real world demands. So, when the ambitious goals were not met because the foundational tech simply was not there, the disappointment was huge, and government funding, which was propping up much of the research, dried up significantly. Despite that setback, hope eventually resurfaced, leading into the 1980s with the rise of expert systems. The idea was quite smart. Let's capture the knowledge of human experts, like a doctor diagnosing an illness or an engineer troubleshooting a machine, and put it into a computer program. These systems generated a lot of excitement and investment, but they led to the second AI winter in the late 80s and 90s for a different set of practical reasons. Building these systems was incredibly expensive and time consuming. They were essentially custom coded knowledge bases that required extensive input from human experts. And once built, they were notoriously difficult and expensive to maintain and update. If a new piece of medical knowledge emerged or a machine design changed, updating the expert system was a huge undertaking. They were also fundamentally inflexible. They only worked within their specific domain and couldn't handle situations even slightly outside their predefined rules. They lacked common sense or the ability to adapt. Businesses invested hoping for revolutionary gains, but often found these rigid, costly systems didn't deliver the expected measurable return on investment, especially as the world changed around them. This led to another wave of disappointment and reduced funding for AI research and companies. So, after two significant crashes, two AI winters where the initial promise seemed to freeze over, why is this wave so different? Why is AI truly taking off now? Well, it's not just one thing, it's a powerful convergence of factors that have overcome those historical roadblocks. First of all, data is abundant and accessible like never before. The digital revolution means we are generating and collecting vast, diverse data sets from every corner of life: social media, mobile devices, scientific instruments, and business transactions. This provides the absolutely essential high quality fuel that modern AI algorithms need to learn complex patterns. We simply didn't have the scale of data during the winters. Then there's computational power, and this is huge. The exponential growth in processing power, particularly with GPUs being repurposed for AI tasks, combined with the affordability and scalability of cloud computing, gives us the horsepower to actually process that massive data. Tasks that were computationally impossible or would take weeks or months on the machines of the 70s or 80s can now be done in minutes or hours. And the algorithms themselves have seen fundamental breakthroughs. Developments in areas like deep learning and transformer architectures mean AI models are far more capable of understanding complex information, recognizing intricate patterns, and even generating new content. Text, images, code in ways that were pure science fiction just a couple of decades ago. They can learn from data in a much more powerful and generalizable way than the brittle systems of the past. Crucially, this combination of data, compute, and advanced algorithms is enabling AI to provide clear, tangible value in real world applications. We're seeing AI automate tasks, personalize customer experiences, accelerate drug discovery, improve diagnostics, optimize supply chains. Businesses and individuals are seeing measurable benefits and ROI. This isn't just academic promise anymore. It's practical utility driving adoption and creating a positive feedback loop for further investment and innovation. All those past struggles taught the field valuable lessons. They emphasized the critical need to be realistic about what AI can do, focusing on specific solvable problems rather than trying to create general intelligence overnight. They underscored the absolute necessity of aligning AI development with real business needs and goals to ensure it delivers measurable value. And they highlighted the power of continuous iteration, recognizing that AI systems can be deployed and improved over time, getting better as they learn from more data and user interaction rather than needing to be perfect and static from day one. Looking ahead, based on this solid foundation and the lessons learned, I see AI increasingly acting as a partner, augmenting human capabilities across virtually every profession rather than simply replacing people wholesale. There's also a critical and growing focus on developing AI responsibly, addressing ethical considerations and transparency as these systems become more integrated into our lives. And we'll continue to see incredible strides in AI driven personalization, tailoring experiences in areas from education to healthcare to consumer services. Ultimately, AI's explosion now is not accidental hype returning. It's the result of decades of foundational work where the necessary pieces, the fuel, data, the engine, compute, and the refined mechanics, algorithms, have finally aligned to enable practical, valuable applications that simply were not possible during the prior AI winters. This convergence makes this era fundamentally different and the potential truly immense. If you enjoyed this video, feel free to give it a thumbs up and subscribe to my channel for more similar content.